Hi, Amelia. Thank you for joining us. We're happy to have you.
I'm happy to be here.
So, before we dive into your paper, I'd like to just start by understanding a little bit about your journey into machine learning and what drives your interest in the space.
Yeah, I would say it was something, and actually, my journey in computer science in general happened very organically, not something that I planned or even anticipated. So, when I started undergrad, I took my first computer science class because my friends were taking it, and then I liked it enough to keep going. And I found that I particularly enjoyed theory. So, I kind of thought that that was where I would end up. But toward the end of my undergrad degree, I had been taking some AI classes and I got a job offer to be a machine learning engineer. So at the time, I thought that sounded more aligned with what I would enjoy than software engineering.
Mhm.
So I accepted that position, and it was in that role, seeing the way that AI models can affect people in the real world, that I realized I definitely wanted to understand more, both about how the models work and then about what happens when they're deployed. And that motivated me to come back to school for the master's degree and to study AI. And then I've liked it, so I've just kept doing it. And so long as those things stay true, I plan to continue with it.
What's your motivation for this paper? This paper is called Better Bench Assessing AI Benchmarks, Uncovering Issues, and Establishing Best Practices. So, what's the motivation behind your work in benchmarking?
Yeah, so we wanted to provide a way for thinking about what makes a good benchmark that's both structured and actionable.
So benchmarks are used to kind of evaluate models. It's kind of what we measure these models against. I guess you can't help in reading your paper but ask the question, but who is evaluating the benchmarks themselves? And so one of the things you state in the paper is that there hasn't been a published structured assessment of AI benchmarking. Why do you think that is, and what's the problem with that?
Yeah, so in terms of why that is, I think that it's really difficult to figure out what makes a benchmark good. And in our paper, we're providing one answer to that, but I wouldn't say that it's the definitive answer or the only possible one. And then another challenge with evaluating benchmarks on that assessment is just that it's a ton of work to do it properly. So for us, for each paper, we had two of the authors evaluate the benchmark, and that meant reading the paper, going through all of the code, and then also any websites or other artifacts available. And on average, it would take at least 2 to 3 hours per paper. So it's just a really big workload.
Just to kind of step back a second, what do you think makes a benchmark high quality?
Yeah, so I think that what makes a benchmark high quality is that it provides you like substantive information about a model. In other words, if I know that some model had some score on a benchmark, then that means I know substantively more about this model's behavior than I did prior to having that information. And I think that that can be broken down into two components. So, first, is there just enough documentation available for me to understand what the score means?
Mhm.
And then second, is the score itself valid based on how the benchmark was constructed and the concept was defined, etc.?
Regarding the problem space, you start the paper kind of outlining some of the concerns related to AI benchmarking. I'll just read a couple. Current benchmarks for LLMs are insufficient for assessing model capabilities, a threat to benchmark utility because of the rapid development in AI models. So, can you elaborate a little bit on the problem space as you see it when it comes to AI benchmarking?
That's a great question. So, situating the problem, we know that we have these scores and we know that they are being used for some things, right? Like they're being published in papers and in people's model releases. And actually, we did another follow up paper where we interviewed people across a range of roles on how they use benchmarks. But the question is, can they support those types of use? And so, for example, regarding LLMs, there's a paper by Timothy McIntosh that I think does really well at going into detail on the problems with benchmarking language models. But basically, there's issues of validity just because of the nature of LLMs. They're trained on data scraped from many sources, and it's very easy for that to accidentally include benchmark data. So there's like this built in problem with validity. And then I think also when we look at LLMs, some of the most interesting questions that people want to answer are about more general reasoning capabilities. But
Mhm.
it's very difficult to disentangle reasoning from LLM's ability to memorize, right? Like I can ask a question that seems as though it's getting at reasoning, but because of the complexity of the representations of these models, it's possible that it had just seen something similar before and it's extrapolating, and I don't think we would call that true reasoning. So it's very hard to measure the things that we care about. And I could be wrong, but I haven't seen yet work that I was super convinced by that was looking at more general attributes. So that would be, I think, the main challenge with LLMs. And then I would say that that does come up with AI more broadly, as the questions that we care about tend to be general. We ask, is this safe? Is it truthful? Etc. And I think even for humans or any other type of system we're building, it's very hard to define what that means outside of a particular context. And so that's an issue that all benchmarks face.
All right, that makes sense to me. So, can you talk a little bit about your methodology and sort of the approach to arriving at these? You arrive at 46 criteria that kind of spanning the sort of life cycle of benchmarking.
Yeah, so the work on benchmarking started with Stanford's AI Index, and this is a document that's produced by Stanford and released to policymakers every year with the goal of informing them about the most important recent developments in AI. And Anka, who's my co author on the paper, was the author of the Responsible AI chapter. And I was helping with that work. And one of the trends that we found that was particularly important from a policy perspective was some general issues with benchmarks. For example, quick saturation or contamination. And because of that framing, we started off thinking about this from the perspective of policymakers. If you're trying to regulate these models and benchmarks are something that's widely available and relatively easy to use, it's likely that they would be some kind of factor in the decisions, and yet there are these issues with them.
Right.
So from there, we started looking at safety related benchmarks in particular, with the hypothesis that those would be maybe the most relevant for regulatory decisions. And our initial aim was to run a bunch of these benchmarks and look both at what was covered and what wasn't covered by them. And there was actually a really great paper at NeurIPS this year doing exactly that on safety washing. So that's awesome, and I highly recommend people check it out. In our work, we started that, and we were struck just by how difficult it was with some of these benchmarks to run them. Like code might not be available, or there were bugs in it, or there were issues in the documentation, etc. And so then we realized, okay, yes, there's these issues of validity, but also even just on the technical side, it can be quite hard to use benchmarks. And we came up with some initial desiderata for a good benchmark based on our experiences and the Responsible AI Index. And then, as we describe in the paper, there were like 6 steps through which we refined all of those criteria to reach the final 46.
Okay, I want to elaborate on that a little more because you have interviewed people, you drew from benchmarking practices in fields other than AI/ML. Can you talk a little bit about that process?
Yeah, we were interviewing people across kind of all of the stakeholder groups for how a benchmark might be used. So the people developing the benchmarks, the people who are consuming the benchmark scores, the model developers, and then also regulators. And I think there was one more, AI researchers. But yeah, we talked to people across those groups about how they use benchmarks and then what they would want a good benchmark to be. And this was a bit more informal than the follow-up work that we did that was like a structured interview study. But we talked to them first at the beginning to see if there were traits that we might be missing, and then again at the end to get their feedback on the criteria that we developed.
And so, what did you draw from other fields, or what like similarities did you pull from fields other than AI/ML?
That's a great question. So I think one thing that I noticed in reading the literature about other fields is that for the type of technologies that were being benchmarked, I think there was already maybe a clearer understanding of how they were going to be practically used. Like I would say for most of us, our ideas about how AI will be a part of our lives are constantly evolving, and we're seeing new use cases and interactions all the time. So they were grounded in the fact that there were already more concrete ideas about the use of these technologies. For example, original benchmarks for hardware systems where you want to just test the capacity of a computer. But some of the themes that came up, a big one that we drew from was the idea of interpretability. For example, there was a paper on benchmarking environmental quality that emphasized first that benchmarks should never be the basis of a final decision, and second, that rather than representing results as absolutes, they should be treated as understandable inputs for decision makers. And I think when we consider something like environmental quality, at least for me, there's a bit more of an intuition about what might go wrong with a misleading benchmark there. You know, if we say,
Mhm.
oh, the water quality is really good, and it isn't, then people are consuming water that isn't good quality. But with AI, again, I think it's more challenging to even have a sense of what that means. And also with AI, I do think interpretability is just harder in general. But still, that theme came up a lot, and it was something we drew from because I think striving toward that is very important. And then another theme we saw frequently that might sound kind of basic was guaranteeing accessibility. So having the data sets and the infrastructure be easy for folks to use. And I will say one caveat to this with AI benchmarks is that there are concerns around gameability. So there can be advantages to not having the data sets publicly available. However, still letting people run the benchmark without interacting themselves directly with the data. Finally, there was this theme of ensuring validity. And so that could be construct validity, which is like, are we measuring the thing that we actually care about? And then also just things that are good scientific practices. Like, is there a big enough test set to allow for statistical significance? Is a benchmark being updated over time to prevent developers from overfitting to it? And if not, are we at least stating these concerns about overfitting or doing anything to have that be in people's context when they interpret the scores?
I want to talk a little bit about designing for downstream utility. That is how it's phrased in the paper. And I'm particularly interested in it now that I know that you had an initial interest in theory. So you emphasize the need in the paper for benchmarks to be situation specific, diverse in use cases, and reflective of practical settings. So given this, what is the role then for theoretical research? Is there a tension between developing benchmarks grounded in real world scenario and theory?
I think there is some tension, but maybe not so much as people might believe. Like, there are cases you can imagine maybe we're at a company and we're trying to figure out how to place advertisements in someone's social media feed and we want to benchmark our click through rate. That's super specific to that task. And if I'm like training a machine vision model, that's not going to be relevant. But I also think that when we're in the academic use case, it still matters a lot to have a specific scenario in mind. And that scenario could be, we want this benchmark to be used by researchers who are interested in advancing machine vision capabilities, something like that. And this actually, we were inspired by one of the papers we read with this criteria because they included use cases and user personas for their benchmark. And that encourages just a much more concrete way of thinking about what the benchmark's goal is
Right.
that I believe all benchmarks would benefit from, and that would bridge this gap a bit between things that are a little bit more abstract and more concrete. Because if we have a benchmark, even if it's just like, I don't know, image classification or something, like many of the classic ones, if it's really clear who this is for and what conclusions they should or shouldn't make, you can imagine that it would be helpful in a broader range of scenarios than if we just say, oh, it's how good the vision model is, something that
Right.
maybe isn't even clearly defined.
Okay. And so talk to us a little bit about the scoring method to evaluate the benchmarks.
Yeah, so we scored 4 categories with different point amounts for each. So 15 points was a benchmark fully met our criteria. 10 points was that the benchmark partially met the criteria. 5 points was that they mentioned the criteria but did not partially meet it. So, for example, if you say, we know that prompt sensitivity is an issue in language modeling, but you don't do anything in the benchmark to address prompt sensitivity. That would be a 5. And then 0 points would be neither addressed nor in any part fulfilled the criteria.
And were you surprised by any of your findings or any of the scores?
So I wasn't surprised by any of the scores on the benchmarks, but that was mostly because I didn't go in with any particular expectations.
Okay.
I think something that was quite surprising was how uncommon it was to report statistical significance. However, in retrospect, I don't think I should have been surprised because that's more uncommon in AI research in general. And actually, I would say it's been in my social sciences classes where I've been reading many research papers from those disciplines that I've learned the most about statistics and constructing a rigorous study. So that was surprising, but it probably shouldn't have been.
You evaluated both foundation and non-foundation model benchmarks, and you also make a distinction between design score and usability score. I'm curious on sort of the importance of making those distinctions and how those operate differently.
Yeah, so I think making the distinction between foundation and non foundation models started off maybe having a more administrative motivation in that we were curating a list of benchmarks to evaluate, and we wanted to be sure there was broad coverage of AI. Currently, with generative models being so popular, many of the benchmarks released pertain to those. So if we hadn't been quantifying and we'd just been, looking at Google Scholar or other sources, we'd probably have ended up with a much more skewed sample. And then we did want to see whether there were any differences because we had that data point that arose from, I guess, the nature of the tasks that foundation versus non foundation models might be tested on. And then regarding the distinction between design and usability, so our usability score is a weighted average of 3 of the stages of the benchmark lifestyle: implementation, documentation, and maintenance. And then design is just one stage, the design stage. We found that there was kind of a natural grouping that took place there. And then also from a pragmatic standard, it allowed us to create visualizations on 2 axes, which was helpful.
Right. Okay. So let's go back to the stages. So you develop a 5-stage benchmark development life cycle and you provide the criteria we already mentioned for each stage. Can you talk to us a little bit about what you're looking for in each stage?
Yeah, and I think something that I want to emphasize about framing around those stages is that it's very important to us to create an assessment that people can practically act on. Part of that is making sure that the criteria are clear, specific, and in the benchmark developer's control. And then part of that was also mapping them to stages of the benchmark development process so that if you're someone making a new benchmark, it's a bit easier to say, okay, there are 46 of these, but right now I only need to worry about these 10.
Mhm.
And our hope is that that will make it more feasible to implement this. And so, walking through the stages from start to finish, design stage, this is like the purpose, the scope, and the structure of the benchmark are being chosen. The tasks are being designed. This is, I think, the most key consideration from my perspective here is like the construct validity. What is it that we care about? How will we measure it? And do those things truly align? And then after that, we have implementation. So, this is what makes it possible for other people to run the benchmark. And then also, are there any protections being added against some of the issues that can come up, such as contamination? This is the opportunity where developers can mitigate and address those things. After implementation, is documentation. So we have a benchmark, it's super well designed, we have a great implementation that anyone could use, but is the information actually available that would allow them A, to use it, and B, to understand what the scores produced by using it mean? After that comes the maintenance stage. So the benchmark is totally completed, it's released in the world. We understand that the world is going to keep changing, and as a result, is the benchmark changing? Are issues that may have already existed with it being addressed, etc.? Any kind of monitoring or responsiveness. And then the last stage, given the rate at which AI is changing, is retirement. So benchmarks, it's not uncommon for them to be either saturated or compromised with contamination. And our hope is that if developers realize a benchmark has reached this point, that they will make that clear that, we think this is no longer providing meaningful signal and the code and everything can still be available, but there's something done in the artifacts to say, we've moved on from this assessment and this is where we've gone next.
Right. And you also have some other design considerations that aren't part of those five stages. Can you talk a little bit about some of those?
Yeah, so when we were coming up with the things that we cared about benchmarks, we found there were some things that were really important issues, but either weren't fully under the benchmark developer's control or where their appropriateness was dependent on the specific scenario. So we didn't want to present them as everyone should be doing this every time because either they can't or they shouldn't. So, some examples of those would be deciding about whether to prioritize something general versus task specific. That's a spectrum, and you can imagine, depending on your use case and the user personas you have in mind, there are many places along that spectrum that are great, but I think it's important in the design process to be deliberate about where you're landing
Right.
and to be actively making that choice. And then another example would be the use of dynamic versus static benchmarks. So a static benchmark, we have one data set and we're not making any changes to it. It's very reproducible, but it's also more gameable and likely to have contamination versus a dynamic benchmark. We know the types of examples we want to have in our data set, but we're able to constantly generate new ones. And you can say
Right.
like less gameable, also less reproducible. And for dynamic benchmarks, it's much easier for some kinds of tasks than others. For example, for math, we can say, okay, we want this equation, and then we can swap out the values, but the structure of the equation stays the same. From my perspective, which is limited, I can't think of it as easy of an analogy for language or other types
Mhm.
of tasks. So it's just sometimes more feasible.
Right.
But again, I think all of the things in other design considerations, I believe, should be a deliberate choice on the part of benchmark developers, where there are many choices that are awesome, but it should be actively a choice.
You have a discussion section in the paper, and one of the things that you point out is models like GPT-4 and Gemini report results on I'm reading this, on the MMLU and GPQA benchmarks without explicitly acknowledging their limitations or quality differences. What is the problem with this?
So I think looking at where this problem stems from, my understanding is that there isn't currently a consensus in the research community about what a quality benchmark is. And
Mhm.
so, assuming the best of intentions on the part of those model developers, there wouldn't be a frame within which to say this benchmark maybe is more meaningful in certain ways than this other benchmark.
Right.
And so, from their perspective, if it's widely used and cited, which are kind of key signifiers of acceptance in the field, then it would be totally legitimate to present those on equal footing. But then when we look at what happens as a result of that, if you're someone who's in the AI industry, you've been doing research, you probably have awareness of the broad range of things that can be done to evaluate a model, which go far beyond benchmarking. And you might look at these scores as a signal, but you're interpreting them in the context of many other signals. And so it's not as much of a factor. But when we consider that these big commercial models are rapidly proliferating, and being used by people who have a broad range of backgrounds, then I think it's more important to provide context that someone who doesn't have, years of AI research can understand. And so I think the aim is less to criticize the way that this information has been released historically and more to suggest that in the future, knowing what we know about differences between benchmarks, there ideally would be consideration of what they are and are not able to tell us when scores are being publicly released.
Okay. Now, in your opinion, should there be some kind of maybe something like this benchmark checklist that benchmarks have to meet, or some kind of score, like yours is a 15 scale score, some score that they have to achieve in order to be sort of classified as an approved benchmark? And then if so, should models have to be evaluated on so-called approved benchmarks? What are your thoughts on kind of those, on like a mandate like that?
So I do think that there are some traits of benchmarks that should absolutely be mandated. I don't think that they're necessarily the traits in our paper. And the reason for this is that there are so many things we can evaluate, and what is appropriate depends a lot on the particular task. But there are things like, did you obtain consent from any individuals who are labeling the data in this benchmark that invariant of what the task is necessary? Or did you provide warnings regarding harmful content in the benchmark? That's also invariant to the task. But those are more lightweight things. I think I would be hesitant to impose a heavier weight mandate on the benchmark developer side. Something that one of the researchers I talked to in the other paper I mentioned, which is the interview study, said that I think is so great and spot on, is that creating a benchmark is a public service. And I do really believe that it's a huge undertaking. And when a benchmark is available and usable, it both allows and can drive a lot of growth in a field. And so I wouldn't want to create a standard that's inhibiting the creation of those benchmarks. Instead, the goal would be that a framework like ours, A, if you're creating a new benchmark, maybe this gives you things to think about to make the best benchmark you can. And then B, on the consumer side, you understand the needs of your use case and you can say, is this benchmark a good fit or not? But I think in general, it would be a much shorter list of criteria that I would mandate for benchmark development. And then regarding the model developer perspective, for research tasks, just because there's such a breadth of things you can model, I think often the tasks outpace the benchmarks, and there are tasks where a benchmark doesn't maybe even make sense as the evaluation criteria. So I wouldn't say modeling research needs approved benchmarks to be published. However, when we look at this from another stakeholder side, from the regulatory perspective, I do think that the idea of approved benchmarks is important, and that in my ideal scenario, the people who are regulating these models would have a clear distinction in the quality of benchmarks. And I would hope that benchmarks often would be one of many evaluations considered in deciding whether or not a model is appropriate.
What are the other evaluations besides benchmarking that you would hold sort of at a similar weight?
Great question. I mean, I think the weighting again is so dependent on how the model will be used. But I would say if we're just looking at this from like a safety perspective, red teaming, both human and automated, is super important. Like doing testing specifically targeting failure cases,
Okay.
and also testing, I think, both human and RL red teaming are adaptive, right? If I'm trying to get ChatGPT to say something undesirable and I see one approach didn't work, I'll try another. And that's also what an RL based model would do. So there's like a flexibility that a benchmark doesn't have, and also a way that this can be tailored specifically to particular models. And then I'm also a huge fan of human evaluation. I think from a regulatory perspective, that becomes much more challenging to standardize. But if I were on the model developer end in production thinking about releasing something in the world, I would definitely want human eval. And something I think is important to emphasize there is that it doesn't have to be always heavyweight human eval. Like you have a team of people annotating all of the responses and interacting with the model. Even just as a researcher, setting aside 15, 20 minutes to interact with your model, you will find behaviors that you didn't expect. And those might either point you in the direction of more automated testing or more manual testing. But there's so much that you can learn just through directly interacting with the model. And I think no one releasing a model in the world should skip out on that step.
We've touched on some of them, but what are some of the open challenges in AI benchmarking that we haven't
Let
addressed?
me think. I mean, AI benchmarking is a really hard problem. I think one thing that we can talk about in more detail is the issue of construct validity, and in general, in any kind of evaluation. That's quite hard. An example I would use is like, let's say we want to benchmark LLMs for kindness. That does seem like something maybe we would want to know. But then I consider, okay, well, how would you evaluate humans for kindness? There's not a great way to do that. Instead, maybe you can break it down into things that are like, oh, did someone let you into their lane while they're driving? Did someone, say thank you when you held the door for them? You can break it down into these discrete tasks, and then you can make a claim about those tasks. But actually, I personally wouldn't want to extrapolate from that to kindness. My opinion is that in some ways, given where we're at currently with evaluations, ideally there would be a scaling down of what benchmarks are trying to measure, particularly with those traits that we don't even know how we would measure in humans.
Okay.
Or that don't have a clear evaluation standard. There's a paper actually critiquing benchmarks for doing this. Everything in the whole wide world benchmark that I think does an excellent job laying this out. Yeah, so I think partly there's just the scaling down of what it is that we're trying to measure, and then also considering, not as a field, considering that to be less important and meaningful. Like, actually, I would rather know, is someone letting you into the lane than are they kind? One of those
Yes.
things I can interpret very clearly and then make a decision that matters for that particular scenario tested, which is driving, but I'm not encouraged to extrapolate like to what someone might be like as a colleague or anything.
Oh,
And even then, with that example, there's still the issue of construct validity. Like, maybe they didn't let you into their lane because they're rushing to go help a friend move. Like, I think being more realistic about what we actually can conclude from any of these measurements, partly in what we're aiming to measure, and then partly in the clarity about how that's being set up. And then also, there's this question of the standardization of benchmark reporting. So there are a number of projects that are aimed at facilitating this by running benchmarks on public models and just putting all the scores in one place. And because the same person's running the benchmarks, we're achieving a greater standardization. But from the model developer perspective, there isn't an accepted community standard for what should be reported and how. And I think that at the very least, beginning that discussion is important when we're looking at it from a consumer perspective. Like, the number of us who consume these models in daily life is only going to grow. And it also speaks to the fact that my impression is, in the AI community, for a long time, this was stuff that we were doing for ourselves, and you could safely make the assumption that anyone consuming these type of models had at least a moderate amount of background that would allow them to understand their performance. And that's no longer the case, and it's
right.
becoming less true. Of course, I hope that our education will catch up with the rate of AI development and then it'll be more true again. But for now, with that in mind, I think having a community discussion of what information do we need to share about models and how, with the expectation that people beyond the community, beyond AI research, are going to be using them in important ways in their lives, is really crucial to figuring out the role of benchmarks going forward.
Right. I think that's a really interesting point. I want to go back to the construct validity a little bit and the
Yeah.
kind of extrapolation to things like kindness. Do you think we're seeing those kinds of benchmarks coming out because of the hype around agents and creating something more human, like getting closer to AGI or whatever people think this sort of sci-fi notion of AI? Why do you think we're seeing that more and more?
Yeah, so I think partly it's this discussion about AGI. And I also think it's really pivotal that the AI models people are most aware that they're interacting with are in a dialogue format. Like, of course, we've all been interacting with AI all the time for years. It's what's powering search engines and Netflix recommendations, etc. But we're not so conscious of it as we are when we go to Claude or Llama or ChatGPT. And that is a format where it is built in to be personifying the AI. And then we start asking questions about its traits that we would ask about a person. I think it's just a really natural place to go when AI is in that format. And then I also think that it's a kind of judgment that we as humans are prone toward making. Like there is a desire to draw back and say something about more general traits. And my personal opinion, which there's plenty of room to debate, is that that's like not such a great thing in general
Mhm.
to be doing. And then it doesn't really matter if we can say, you know, oh, this person is kind versus like, I'm happy with how this person treats me or
Right.
that type of thing. So, broadly, I think more specificity in why the trait matters leads to less of a need to generalize about that trait. If you're interviewing for a job, they're not going to give you an IQ test or something, even though they might say that they want to hire intelligent people. Partly, that's because there are huge issues with the validity of IQ tests and the history of that. And also partly because at the end of the day, it's not really what matters. What matters is like, what would it be like to work with you on the job? Will you be able to solve the types of problems that you encounter? Are you behaviorally someone who's a pleasant coworker? And so I would hope also that as we gain a more concrete understanding of the role AI will play in our lives, it also will be natural to maybe veer away from these like general and personified evaluations toward things that more directly relate to the way it's used.
So I'm curious, are there considerations when you're talking about benchmarks for different types of AI fields? And you kind of mentioned this with language, like mathematical things are very kind of sort of, I guess, black and white, and then language maybe has different considerations. So are there considerations that you need to keep in mind depending on the AI, the type of research you're doing in AI ML?
Definitely. I think one example of this would be that if you're doing any kind of AI for health, there's a huge range of considerations that I think you're more immediately aware of because we're like, okay, in some way, this will be either a technology that interacts with doctors and patients or that leads to a technology that does. And so evaluating with the type of safety risks that can come up in mind. And also when we look at benchmarking for AI for health, Shreya Johri at Harvard has done really wonderful work on this. And it's very directly embedded with clinicians. So that might be of more of a concern there versus if what you're interested in is understanding these models' ability to do algebra, you might not need to have as much of an expert perspective on that. Because of the lab that I'm in and the type of problems that I work on, something I think a lot about is like, is this application or potential application safety critical? Because many things are not. I think that when we look at the work out of DeepMind, we've seen huge advances in AI and our understanding of AI just related to the ability of these models to play games. So that's hugely valuable to have benchmarking for that and to be creating new algorithms. However, what I need to know about a model's ability to play chess is different from what I would need to know about its ability to give guidance to clinicians. And that's not to say that either of those is less significant scientifically. There's just different challenges and constraints. Yeah, it's quite dependent on that broad question of like, do I think this will end up being safety critical? Yes, no. And then if it might be, like if we look at language models, they can be deployed, for example, for health in ways that do have those implications. However, they can also be deployed for things like assisting you in writing your emails or changing your grammar that are not. So I wouldn't say that every language model evaluation has to be done with that in mind. And hopefully, so long as there's really great clarity in the way the benchmark is documented, no one would reach a conclusion that wasn't validated by the information provided by the benchmark.
So this is not a criticism of benchmarking. It's more outlining of a problem space and sort of considerations that people could consider in creating benchmarks or evaluating benchmarks. So what would you like people to get out of this paper?
Right. So I think, yeah, it's definitely not a criticism. And I wouldn't even interpret it as a criticism of a benchmark that received a low score. Like, we're proposing the set of normative standards about what a benchmark should be. But A, you know, this field is evolving, and maybe 10 years from now, some of them will disagree with. And B, if you were actually to be using these criteria in real life, you wouldn't be doing one of the key things we're doing, which is weighting every criteria equally. Like for a downstream application, they're just not all going to matter the same amount. And so the
Right.
hope instead is to provide a lot of clarity about what are the criteria, where did they come from, why, so that people will be able to make their own decisions based on the scores. And maybe they'll say, hey, this benchmark had a really low average, but it did amazing on everything that I care about. And so I'm going to use it regardless. And I think that would be a great outcome of this paper. And then, yeah, I think I just see it as one theory that we have done a lot of work to validate, and that I would be comfortable defending any of these points. But that doesn't mean that I think this is the only right answer forever.
Okay. So what do you have coming up? What's some future work for you that we can look forward to?
Yeah, like I mentioned earlier, my primary work at Stanford is with the Intelligent Systems Laboratory. And this is an autonomous vehicles group. Although I'm doing stuff on benchmarking and language modeling, it's in that framework where we're thinking a lot about safety all the time.
Right.
And so on the evaluation side, I've been doing work with autonomous red teaming, basically giving another frame for understanding a model's behavior that could be complementary to benchmarking or just dependent on what you want to know about a model better. And then I'm also doing work in early stages that I'm super excited about, that's applying a reinforcement learning formulation to the information retrieval task. If it's all right, I'm just going to give my like hot takes on reinforcement learning and
Sure.
language
Yeah.
modeling right now. So when we think about what language modeling and these type of tasks has been, we have things basically where we're trying to maximize the probability of saying the correct thing. We want to be predicting the mass token in the right way, and then generating the sequence that per our model is the most likely. And we have post-training options on top of that that are saying, okay, we have some preferences, either paired data or we have a reward model, and we want you to be doing the thing that we think is good. But when we consider the way that people actually interact with language and through language, neither of those paradigms is what I think is happening. Like if you even look at, I mean, it's especially clear with like children or when two people don't speak much of the same language. There's a lot of disfluency and confusion, and things are not perfect, maybe not even particularly likely. But that doesn't mean that any of these conversations are not good. In expanding the way that we think about what makes language, particularly in a conversation setting, but beyond it, good, this allows for the development of new modeling approaches. And in particular, I think a reinforcement learning framework can be great for that, because one of the things that it enables is taking an information gathering step. And if we think about what we do in conversation, that is happening constantly, right? We're always saying things, and then you can see how someone responds. Like if you say, oh, how was your weekend? And they say, oh, it was awful. You might not, keep asking about it.
Right.
Versus if they say it was amazing, I went to Yosemite, you could say, like, what did they do there? So there's this flexibility. And I think also this idea that making mistakes is not bad. What we want is to be able to be highly responsive to the feedback we're receiving so that we can recover from them.
Right.
So I think any approach to language and language related tasks that leverages those attributes is really exciting. And coming back to the problem of information retrieval, current methods tend to be very dependent on like an idea of similarity between a document and a query. And they are highly effective. I'm not saying that that's a bad approach, but being outside of an RL framework, there isn't an ability to learn more about other parts of the space of documents
Right.
that we have. Like if I have a homework problem that I'm working on and I'm trying to find resources about a particular concept, maybe I start off with one query and I find some things, and then I'm like, oh, actually, this is making me think this isn't that useful. But now I realize that what I actually want is over here. Like that's something that we do when we're searching for documents. And I think a level of that can be built into the search itself through RL algorithms. So I'm
Right.
really excited about that work. And I think about approaches to AI in general that emphasize adaptivity and recovery rather than immediate high accuracy,
Right.
particularly systems that are engaging with humans in non-critical settings.
Yeah, that sounds interesting. I'm really excited to stay up to date on the releases. Hopefully, you'll let us know when we can discuss those.
Yeah, no, I would love to. It's a really exciting time to be working in these fields. And there's so many papers from other people that I'm like, oh my gosh, that was so cool. I could talk about that for hours.
Thank you, Amelia, for joining us and for your time. We appreciate it.
Thank you so much. I really enjoyed talking to you.